Hello, good afternoon. Welcome to the Joy of DevEx, which is a talk about tightening the developer feedback loop in Kubernetes so that we can help improve the developer experience. If I may just start with a little brief introduction about myself. My name is Revell-Gordon, and I'm a senior platform engineering consultant at OpenCredo. And OpenCredo is a data and platform engineering specialist consultancy. We happen to have a booth out in the hall, so if you haven't said hi already, please do come drop by later. I personally have worked in the DevOps and platform engineering space for around 15 years now, and I specialize in cloud infrastructure, CI/CD automation, and of course, managing tools like Kubernetes. During my time with OpenCredo, I've worked with Kubernetes on many engineering projects that we've done with our clients, and it is my experience with some of these projects that is the inspiration for this talk. Something that comes up time and again when we're on these engagements is that working with cloud-native technology throws up a few challenges, specifically the fact that if something is cloud native, it's designed to run in the cloud. And if it's designed to run in the cloud, then it makes sense that it is designed to be meant to be tested in the cloud as well. However, a key part of having a joyful experience, whether you're a developer or of a platform engineer, is to be able to test and develop things rapidly. And an important component of that is to be able to do things locally on your laptop. And herein lies the challenge. Your laptop is not cloud native. Now, sure, there are, of course, a few things that are relatively easy to do in isolation, so linting or unit testing might not be such a problem, but as soon as you get towards integration testing or other forms of testing, specifically if you're trying to test the configuration and the deployment of your infrastructure in of itself, that is a bit more challenging. Now, there's no getting away from this to some extent. Your laptop is always going to be limited in some way compared to the cloud. You're going to always be needing to test in a cloud environment at some point in your journey. But that doesn't mean that we shouldn't try and improve and supercharge our laptop setups to make it as much like the cloud as possible so that we can do more than we'd be able to do otherwise. So a common experience on our engagements with our clients is that occasionally we have an ethos where they say, don't test on your laptop, just test it in the cloud. And this often results in a very lengthy feedback loop because I'm sure you've been in a situation like this yourselves, where you will queue up your pipeline, it might go in a queue for a little while, and then it eventually starts bootstrapping. You see that innocuous amber disk spinning away whilst it's doing its thing, and inevitably sometimes it will fail. And often it will fail for some very irritating, innocuous reasons, such as a stupid typo that you and your linter was unable to catch. And every time that happens, you have to go through that whole process again. And the more congested and busy your CI environments are, the longer that loop is going to be, and the more frustrating it's going to be. So this is why we often, as engineers, will turn to our laptops and do things locally. But not everyone will want to tinker with Kubernetes and try and make things as accurate as possible. They may take a shortcut, and we've experienced this on a lot of engagements as well. We've worked with developers who will use something like, for example, Docker Compose instead of Kubernetes, a much more lightweight and simple solution to test integrations between multiple services. And we were on one particular engagement where this was the case. The team of developers had worked really hard and put out some excellent work, and they tested it, and they'd even showcased it to the stakeholders on their laptops using Docker Compose. And of course, the stakeholders said, this is fantastic. I can't wait to see this in production. So they went about pushing it forward through the CI environments, and as soon as it came in contact with Kubernetes, it didn't work. And it didn't work for the fact that they didn't consider that there were some changes to the ingress controllers that now need to be made to accommodate their new services. And obviously, if they'd been using Kubernetes on their laptops, they may have sussed this out earlier. They could have engaged with the platform engineering side of the team, and we could have planned for this work. As it was, we had to have that very awkward conversation between the Scrum Master and the engineers about whether we're going to push this work out to the next sprint and delay the release, or whether we're going to parachute it in and push out, yada, yada, yada. Which is what we did in the end, because the stakeholders were really keen for this particular thing. But nonetheless, there were some very anxious and frustrated developers whilst that negotiation was going on. There was another incident with an unfortunate developer who had tried to develop something to do with environment variables and interpolation. I'm not quite sure what he did, but he somehow tied it to a feature of Docker Compose itself. And of course, again, came into contact with Kubernetes. It didn't work. And it turned out that there wasn't a way to emulate or do the same thing that he was doing using config maps or the like. He basically had to go back and re-engineer his solution, which was not a good experience for him. So if we're running Kubernetes in the cloud, then we have to be running Kubernetes on a laptop. And that may not be such a big deal, you ask. I mean, these solutions exist. We have things like Minikube and Docker for Desktop, also has a built-in Kubernetes cluster available to you. Well, speaking certainly as a platform engineer, if not as a developer, I find this doesn't really cut it either. So there are some limitations with this approach, specifically that you will only ever have a single node. You have no control over the specific Kubernetes version that's running, and quite often these setups don't use the official upstream of Kubernetes, or not the same upstream that you'll be using in the cloud, which means that you're not getting a clear representation. So doing anything such as testing node affinity, or testing a rollout strategy, or testing an upgrade path from one particular Kubernetes version to another, you can't really do that in that setup. And a side anecdote, there was a colleague of mine who was working on a different cloud-native product, Kafka, which is a data streaming product. And he tested something locally on a single instance. And it was only when he started testing things with multiple shards that there was all sorts of problems that came out of the woodwork. So it's worth bearing in mind that it's not just the tools that we use, it's the shape and the structure of them that matters as well. So what should we do? Should we just emulate the whole cloud? Should we try and stuff an entire copy of AWS or Google Cloud into our laptops? It's crossed my mind whether that's actually possible. Maybe it is, but to be honest, I don't think that's a particularly practical solution. If we did achieve that, I'm not sure it would be particularly helpful either. But what we can do is emulate bits of the cloud. We can emulate the things that are preventing us from replicating what we're doing in the cloud on our laptops. So what would my approach be if I were to give some advice to people who are thinking of going on this sort of journey? Well, first of all, I would treat this like any other platform, any software or engineering project. Take the iterative approach. Focus on the thing that is giving you the biggest pain point, or the thing that is going to give you the biggest payback if you can solve that problem, and start from there, and then iterate and add things as it goes. There's no need to make this all things to all people at the very start, same as we do with any kind of software. There are a couple of anti-patterns which I've established whilst I've done this a few times with our clients. And the first is to avoid creating local versions of your manifests. So this is where you may be tempted to say, well, the ingress controllers aren't working, this bit isn't working, let's strip all that out and just have the bare bones and we'll just fudge the rest of it around. Well, that leaves you in pretty much the same situation as if you're using Docker Compose. You fundamentally changed the shape and the nature of your infrastructure. It's not giving you a comparable representation of what you're running in your production systems. And then you've also got the added headache of having to run two systems, of having to manage two systems in parallel. The other thing to avoid is changing your existing manifest or your existing production setup in order to make things easier to test. You know, there's no way that you would make that decision, right? You wouldn't say, let's not do this in production because it's hard to test that locally. We're going to do something else. The objective of this is to do the exact opposite, is to manipulate your laptop or do something locally that allows you to replicate what you're already doing in production. So I'd like to take you through a little example that was based on a real-world solution that we did for one of our clients. So let's start with a representation of a fairly typical cloud setup. So here we have something in AWS, where you, of course, will be using an EKS cluster. And we're running Kubernetes version 1.31. And our cluster spans across 3 availability zones with a control plane node in each, and at least one worker node, though in production. Hopefully you'd have more than one in each. And typically in AWS, you also install the load balancer controller, which means that if you have a load balancer service, then you would get a network load balancer provision for you automatically, which will give you network connectivity. So let's compare that to what you would typically get on your laptop. Now, I've chosen to use Colima, but if you're not familiar with Colima, it's an alternative to Docker Desktop. It does literally the same thing. It gives you access to the Docker runtime. And like Docker, you can flick an option that will give you a Kubernetes cluster. But what you get is actually a K8S server. So K8S is a very cut-down, minimized version of Kubernetes. It does a great job. It has some great use cases. But if you're not running K8S in production, if you're running Kubernetes with K8s, you know, the official releases, then that's not the same thing. There is no control over the Kubernetes version, so it may not be the same that you're running in the cloud. And you will only have this single combined control plane and worker node. And as far as I'm aware, the networking, it just cheats and does a blanket port forward to give you connectivity to inside the cluster. So what we endeavored to build instead looked a bit more like this. Now, obviously, it doesn't look exactly the same as on the left still, but I'm sure you'll agree it is now much more comparable. Instead of using the built-in cluster, I'm now using Kind to deploy a Kubernetes cluster, which allows me to deploy a multi-node HA-like cluster with multiple control plane nodes, multiple worker nodes. And you'll note that I've replaced the load balancer controller with the Metal LB controller, which is intended for bare metal installs, but it's a way that I got around the problem that obviously you can't install the load balancer controller for AWS on your laptop because that's not going to do you any good. And we needed some way of making sure that the load balancer services were functioning. So for me, I'm just going to take you quickly through some of those choices. So Colima, as I mentioned, this is essentially the same thing as Docker Desktop. It creates a Linux-based virtual machine on your host so that you can interact with Docker. But compared to Docker for Desktop, it is much more lightweight and it is highly configurable. The thing that is best about it is that you can actually have direct control over the virtual machine. You can SSH into it and play about with it. You can run init scripts, and you can even author your own version of the virtual machine. You can fork it and run your own should you have a need to do so. So it gives you a lot of options to play with there. Kind, if you've been to any of the talks already today, I'm sure you have. It's come up quite a few times, so I'm sure most of you are aware of what this is, but in case you're not, Kind is Kubernetes in Docker. It's a officially supported project with its own special interest group for managing Kubernetes clusters in Docker. It allows you to deploy complex multi-node deployments, and their base images, which is a big selling point for me, are based off of the same source as the Kubernetes releases, and they follow the same release cycle. So if you're using their nodes for the corresponding Kubernetes version that you're using in the cloud, it is the same. You can even plug in EKS source code as well. There's a way to get the same builds that are used in EKS nodes into Kind as well. So if you're running an AWS, that is a plus as well. And as I mentioned, Metal LB is basically a controller which will provide your load balancer services with an external IP address. So when you put this all together on a Mac OS host, which is the typical choice, shall we say, it looks a bit like this. So we've got my Mac OS host, we've got the Colima virtual machine running Docker, and inside there we have our Kubernetes cluster running in Kind with our Metal LB controller. And you'll note that in the middle there are 3 network interfaces. So one challenge that I faced when I was building this solution was that the networking wasn't done for me, so I had to take care of that. So I had to ensure that there was routing available between the bridge network interface through the primary Colima interface in the middle through to the Kind network, which was provisioned when the cluster was started. Now, there's a saying that actions speak louder than words. So I'm going to take you through this now. I'm going to provision for you a multi-node Kubernetes cluster and deploy a simple app to it with some node affinity and a load balancer service, which I should be able to access directly from my Mac. So I've managed a little script to help make this a little bit clearer so everyone can see what's going on. So first things first, make sure that the Colima instance is running. For various reasons, I decided to have it running already rather than have that part of the demo because it wasn't particularly interesting. So the first thing that you're going to see is I'm going to build a Kubernetes cluster using Kind. So there we go. And you can see the command that I've used at the top there includes this config file. This will take a couple of minutes to do its thing. So whilst that is happening, I will show you the config file that I've used. So you can see that we are creating a cluster with the name demo. And there is a single control plane node and 2 worker nodes. Each node has an image defined, which sets the Kubernetes version to version 1.31. And the 2 worker nodes both have an app label with a different value, which I'm going to use to do the node affinity. Perfect timing. Right. So the cluster has been built, but now we have nothing running. So let's deploy something. So there we can see I've deployed 2 pods and a service. Again, there's a YAML file there, which I can show you, so you can see what was on the inside there. So the 2 pods are basically the same. They don't do anything particularly exciting or groundbreaking. They're just HTTP echo servers configured to spit out some distinctive text. So the first one spits out hello, and the second one spits out KCD UK. They both have a node affinity definition. So the first one should only schedule on a node where the app label has a value of hello, and the second should only schedule on a node where the app value is set to KCD UK. So let's take a look at what we now have running. Let's take a look at our nodes first of all. So you can see our control plane node and the 2 worker nodes are all running the correct Kubernetes version. And the two worker nodes both have an app label, as we saw in the config file, with their distinctive values. If we now look at the pods themselves, you can see that they're both running. And the Hello app is running on demo worker node, which corresponds with the app label. KCD UK is running on worker 2, again with the corresponding label. So we've tested that our node affinity is indeed working. However, if we now look at the load balancer service that we deployed, it has no external IP address. It will sit in this pending state forever, and that's because we don't have any controller to manage that. So let's fix that and install the Metal LB controller. So you can see there's a huge number of resources been created. I won't go into the detail there. This has come specifically, it's come verbatim from the Metal LB website. The important bit is just the deployment and the daemon set. This command at the bottom is basically waiting for those to start. So whilst we're waiting for that to happen, I will show you the configuration file, which I will need to deploy in the next step. Now, the important bit here is the IP address pool. This obviously defines the range of IP addresses that the Metal LB controller is allowed to assign to any load balancers. So this needs to be configured to be within the range of your kind network. So if this isn't that range, then you'll need to change that for your particular configuration. This other resource here, the L2 advertisement, is essentially a placeholder. In some production use cases, you would need to configure different items in here for which nodes are allowed to publish and broadcast the IP addresses of which load balancers. But for this use case, it's not really relevant. It simply has to exist. So we can see here that the controller and the other pods have all started. So let's apply that configuration. And if we test the service again, you'll see that we now have an external IP address. However, we are not quite done. So if I bring you back to this diagram briefly again. So we have the macOS host with our Colima virtual machine. We've spun up our Kubernetes cluster with kind, and we've deployed the Metal Load Balancer controller, which has given us an IP address. However, we have not yet taken care of the networking. I need to make sure that there's a route on the macOS side that says direct all the traffic through the col0 interface. And I need an IP tables rule inside the VM to say this traffic is allowed to pass through. So in order to do that, I need to collect a bit of information. So you'll see there's a variety of janky commands at the top there, where I'm deriving this information from various places, including ifconfig and the IP command from within the Colima virtual machine itself. But if you look at the summary, you'll see that we've got the IP address for the bridge network interface, the IP address for the Colima primary interface, and the CIDR and interface name for the kind network. So that allows me to run the following two commands. So the first command is run on the Mac itself, and the second command is run inside the virtual machine, and that should now hopefully be all done. And if I now take this command, I should be able to access from inside the machine. And there we go. Now, this demo obviously shows this concept in its most basic form. There's many things that I've had to cut out to trim it down for the timing of the demo. Some notable features that I've left out there that would definitely want to go into a solution such as this would be to configure a local container repo. And that's because if you don't do that, then obviously you've got to build your container and publish it to some container registry somewhere, and then in order for it to be pulled back down again in your test cluster. But if you configure a local container repo, then you can simply build a container, test a container, build a container, test a container. That will really tighten that loop significantly. And obviously, there's going to be any plethora of external services that you may need to stub or emulate, so a database or S3. There's so many out there, I didn't think it was worth sort of writing off a big list of them. But an important point to mention is using something like Customize to patch your manifest. This will help make sure that you're not adulterating your production manifest, you're doing it in a more transparent way. So for example, your local container repo, you're going to need to change the reference to your container. That will allow you to do that in a way seamlessly over the top. But the key thing to remember here is that this is one solution that I came up with. But I encourage you all, if you're going to go on this journey, to experiment, because there are many different tools and frameworks out there. There are different tools for spinning up local Kubernetes clusters. K8S is another notable example. And they all have sort of different strengths and weaknesses. So experiment and go with whatever works best for you. But ultimately, the key message that I'm trying to get across in this talk is to share the joy. If you're someone like me, I'm sure many of you are in a conference about Kubernetes, you like tinkering with these things and making things like this work. But bear in mind that not everyone does. As I mentioned earlier, you often have developers who are purely focused on developing their apps. They're not really interested in the infrastructure. So if you've come up with a solution like this and built it, make sure to automate it, make sure to package it up if you can, publish your scripts and tooling to make sure that you can share it with your teams so that your developers can have a one-click install that gives them all the framework that they need to be able to test their apps seamlessly in an environment that represents their production environment and have a bit more of a joyful experience. So, to wrap that up, we cannot avoid testing in the cloud for cloud-native technology, but testing only in the cloud can be frustrating, and it can be time-consuming, and it can also, of course, add cost to your development cycle. But with a little bit of creativity, we can tighten that loop and add a bit more joy to the developer experience. Thanks for coming.